Atomic Structure and Symbolism is part of the Flipped Learning and General Chemistry series. This video will review the three basic parts of an atom and introduce you to the shorthand notation chemists use to describe these parts. After completing the assigned problems, you should know the components of an atom, be able to use an atomic number to define an element, use a mass number to define an isotope, and use atomic charge to count electrons. There are three components in an atom: protons, neutrons, and electrons. The protons and neutrons are found in a cluster called the nucleus at the center of the atom. Most of the mass is in the nucleus, and it has a positive electrical charge because of the protons. This is balanced by the negative charge of the electrons surrounding the nucleus. Although the electrons occupy a much larger volume of space than the protons and neutrons, they contribute only a tiny fraction to the atomic mass. Now we're going to look at the periodic table and talk about chemical symbols and the shorthand notation used by chemists. The elements are defined by the atomic number, which tells you how many protons are in the nucleus. Hydrogen, with an atomic number of 1, has 1 proton. Helium has 2 protons, lithium has 3, and so on. When we write complete chemical symbols, the atomic number goes in the lower left-hand corner. However, it's usually omitted because it's redundant. The symbol Li for lithium already tells us the atom has 3 protons. The atomic charge is shown in the upper right and gives the balance between protons and electrons. A neutral atom has no net charge and an equal number of protons and electrons. Ions are atoms or molecules with non-zero charge. Cations have a positive charge, and anions have a negative charge. Lithium is often found as a +1 cation, which means it has 2 electrons to go with its 3 protons. The final piece of information is the mass number, which is the sum of protons and neutrons. Most elements have several possible mass numbers, which we call isotopes. Isotopes are atoms with the same atomic number but different mass numbers. This example is lithium-7, which means it has 4 neutrons to go with its 3 protons. Each element has a unique number and distribution of stable isotopes. In the case of lithium, there are 2, lithium-7 and lithium-6, and they happen to be found in a 92:8 ratio. Each element also has radioactive isotopes. These are unstable combinations of protons and neutrons that will decompose into other elements over time. Lithium-8 is unstable and will decay completely in a matter of seconds. The periodic table gives us another useful piece of information for each element called the atomic mass. This is the weight in grams of 1 mole of the element. Atomic masses are fractional because they're the weighted averages of the stable isotopes for that particular element. For example, if you take a natural sample of lithium, 1 mole will weigh 6.94 grams because it's mostly lithium-7 with a little bit of lithium-6 mixed in. Most of the time, atomic symbols don't have mass numbers, which means you can assume the natural distribution of isotopes. This is convenient because then you can use the atomic mass to calculate moles. Okay, now pause the video and try these problems. Use a periodic table to find the answers. The element is iodine because it has 53 protons. 74 neutrons gives us a mass number of 127, and an excess of 1 electron makes this an anion with a negative charge. Notice that the 1 is dropped and the charge is written as just a minus sign. 26 protons is iron. The mass number minus the atomic number gives the number of neutrons, which is 32, and 24 electrons are needed to create a +2 charge. Don't forget to complete the problem set and read the textbook sections assigned with this video. You should come to class prepared to describe the subatomic parts of an atom symbolically. Thanks for watching.